Hello everyone. We will be working on Python plotting using Matplotlib. This is a library in Python. So our learning objectives are creating a plot, and in that plot we would add more detail and then mention the parameters, define the parameters, add the parameter values, change those parameter values so that we can add color, different style, or if you want to add some text or annotation within your graph, you can also add that. We also need to add labels in the axis, and sometimes it's a good idea to control the limits as well. We will also add in some graphs some titles, but in publication you will see that you don't need to add the title before, you can add the title after when you will be writing your documentation. Also, sometimes we add subtitles, but that's not a good practice to add subtitles. And then we will be creating plots. After creating the plot, we will add some legends. And sometimes we want to create multiple plots in one graph area. We will divide the area and then we will add different plots, maybe 2 by 2 or maybe 2 by 4. I will show you all. So over here I gave you the Jupyter notebook. In that Jupyter notebook I also added 4 activities. When you will be working on this notebook, try to work on those activities as well. Now I'm going to open this Jupyter notebook on my Jupyter session. Before you do that, make sure you install Miniconda, then you use Jupyter as a local host following this module page. If you didn't do that, go back and do it. And you also need to install all libraries. I also showed you in here how you can install all libraries. After you are done with these 2 steps, then you can work on this Matplotlib. Okay, so let's hope you did it. Now our plan is to create some plot. Now how we can create a plot? In Python you can use Matplotlib library so that you can create publication quality graphs. So I gave you a little bit of detail where it came from. A postdoc actually working on creating publication quality graphs. Then again, they actually created Matlab. I worked a long time ago on Matlab, and you can create really nice graphs in Matlab. And they actually use the main techniques in Matlab into Matplotlib so that we can work on Python. To know more about Matplotlib, there is a dedicated website. You can take a look at here, and then they also have GitHub page. You can get the detail from their GitHub page as well. So I mentioned to you what are our objectives. So what we can do in Matplotlib. Later on, when you will learn how we can use Rasterio, GDAL, and then NumPy, then you will see you can mix the your knowledge how to create plots using Matplotlib. With those libraries, we can create geospatial graphs. So you can see that I gave you a graph where we have the Atlantic hurricane tracks. So you can see all the tracks are there. So we can also, if we have the data, we can create a graph and then show the pattern. And what kind of graphs you think we can create using Matplotlib, you can take a look at the detail over here. So you can see that in Matplotlib dedicated website, they provided lots of help what type of graphs we can create. We can create bar graph, we can create a horizontal bar chart, or let's say you are interested to create some 3D graphs, you can also do that. And then later on we will be working on creating some spatial graphs using all the techniques we will be learning here. I'm just giving you an example. If you want to know more, or if in your professional life, if you want to create other types of graphs, box plots, or maybe histogram, you can also create that. Okay, so how we can plot? We have to use plot function. In plot function, before we have to mention the name of the library. So the library we are using, as I told you, is Matplotlib. So we are saying that Matplotlib, we are going to call it as PLT. You can use any other name, but this is a general name people use. So I'm calling it, rather using a big name, matplotlib.pyplot. I'm just giving it a smaller name so that I can use it in my plot. Just like use it in ArcPy, you always mention ArcPy dot. Now we will be using PLT dot. So that means that's our library. Using that library, we can plot our graph. So at first you need to import the library, and then you can work on this module today. Okay, so I added two lists. So you can see that X and Y, we have two lists here. I would like to plot X versus Y. So X will go in X-axis, Y will go in Y-axis. And just like you, I don't know whether you worked on R, so just like we plot in R, we can create a scatter plot. In scatter plot, we have the relationship between two variables. So here we created two variables and we are going to plot them. So for plot, PLT is our library, the short name, dot plot. Okay, let's Control Enter so that we can plot it. You can see that we did not define anything else like the limit or levels, nothing. So it used the default and it gave us those 3 points. So you can see X versus Y. So it gave us those points. So 3 points are plotted here, but they joined those points. So points are 4 and 8. So you can see the first point is X-axis is 4, Y-axis is 8. And then next value is 5. And then for value X value 5, the Y value is 10. That's what we plotted in here. It's not a nice graph because we did not add anything in there. So let's say you want to add blue circle marks in your graph. In the same graph, we added one more element. Now you can see that since we controlled it, we say that what we want, we say that we want a blue dot. So you can see BO, that means it's actually providing me the color blue, and then O is the symbol we are using here. Those are not joined, the lines are not joined. We just ask for a point graph. If you only plot X, you can see that it's only using the ranks. That means this is the first index, second index, third index. So it's going to plot based on what's the index number we have. So for the first index we have 4, second index we have 5, and then last index is the, you can see in here it's 8. So that means it's plotted 8 if we only ask for one variable. If we say that give me a red plus sign symbol, then you can see that the Y value is plotted based on the index number because we only ask for one variable, and then you can see the symbol is different now. But how we are doing it? So what are the possible symbol for marks, possible symbol for lines, possible parameters for controlling X-axis, Y-axis, and labels? So here is the basic structure. You can see that at first we mention the X-axis and Y-axis variables, Then what's the color? Then we can say that color equals, what's the color? Let's say red, or maybe green, maybe blue. So inverted commas, we have to mention that. Marker, that means what's the symbol of your points. So you can see this is symbol is a plus sign. So you can mention the symbol here. Line style, so that means is it a dot line, or is it a straight line, or other types of lines you can also use here. And what's the line width? You can also say that line width is 1. That means it will be default value is 1, but then again if you use 2, it will be thicker, the double than the default. So I mentioned that what are the parameters we can add. So basically I'm right now adding 4 of them. So in those parameters, we can say that what's the symbols for those points. So you can see if it is just the dot, then it will give you dot like this one. If you add a comma, it will just add the symbol like comma. If you add 1, it will be more like Y. And then if it is 2, it's more like this symbol. So if you change this name, then you will see that the symbol will be changing. You can see we have other symbols are mentioned here. So line styles, if you use colon, then you will see that the line will be joined using this symbol, and true dash, then you will see this symbol, and a dot dash, it will give you a line like dot dash. So here are 4 kinds of line style I gave you. Also for color, we can say I would like to get a black color, or you can say no, I want to use other types of color. You can use rainbow or cube helix, but people say that it's better not to use the camp color. This is the kind of color, maybe gradual color. You will see that sometimes, maybe let's say we have elevation map, and then we want to add a gradual color from black to white, or white to black, or maybe green to lighter green to darker green. Then you can use those color ramp. There are more colors we can add, and you can add also the name of those color. So in this activity, I ask you to create a graph and add the following. Add 2 lists, create a scatter plot just like I showed, and in the graph add a symbol for points, join those points to show the lines, also add a line width 2, and add a color. So basically you can follow what I have shown you in these graphs. Okay. So after activity 1, we have axis levels. How we can add axis level? You can say after creating a graph, you can say plot plt is the library, and then say x level for, and then after x level add a bracket, and within inverted commas you can say what you want to add as a level. Same thing for y-axis level. Similarly, we can add the limits, and then you can add this axis function. After that axis function, you have to mention the limit for x-axis, where to where, and the limit for y-axis. So everything I shown in here in this example. So you can say I added the same x and y variables, and then I plotted them. Plotted x and y using the default line style and color. So I said red dot, but then again I said also add the y level and x levels. Y level I want number, x level I want series, and then I said the limit for x-axis is 0 to 10, limit for y-axis is 0 to 30, and then plot it. So that you have to plot them together, you have to run them together so that you can get the plot, because after creating the plot I added these levels, I added these axis limits. So you can see I added the axis limit for x-axis, y-axis level, and then limits, and then limits for y-axis, and then red dots we added. I added another activity for you. So using the same graph you created in activity 1, I would like you to add the add axis levels for both x and y axis, because previously you did not add that. Now you also need to add axis limits, just like I showed you in here. After this activity, you can work on plotting multiple lines in one graph. So previously we just created one graph, and now we want to create multiple graphs within one graph area. So you can see that I created evenly sampled values. That means the number of values we have in these two variables are same. So I say that it's from where to where, and then how we are going to add the value. That means every two other values we will have in here. If you're not sure, then you can always take it out and take a look what we have in T and T1. And then I'm going to plot them together. So you can see I said plot T versus T. That means it will be a diagonal graph. And then I said that the first graph will have the red color and then dashed. And then second graph we have the T versus T1 variable values. That means in x-axis we will have T, y-axis we will have T1, and then green dot dash. That's the symbol we are going to use. We are also going to add labels in our x and y-axis. So you can see that we plotted two lines together, and then in those lines we added, first one is the red line, and then that's the symbol, and then the second one is the dot dash, and then T versus T1. So we plotted them and we added the labels. If you want to add one more graph in here, you can add that plt.plot, and then you can plot them. Similarly, I separated them. So I said that we have the values. We want to create a space for this plot, and then in that plot we are going to add x versus y. But you can see that right now I changed the color. So I said that I'm going to add the parameter color, and then color equals red. I gave you the list. You can change it to other colors. You can see that the marker symbol is 1, line style is dash, and line width is 2. So that means it's going to produce a diagonal. So you can see, because the x and y axis value, we did not define them. If you want to have more space, you can add more limits on both axes. So over here, I added the axis. I said that I would like to limit them 0 to 25 and 0 to 5 should be the limits for x and y axis. So you can see I added, and then I increased the width of the line. That's the difference in here. Also you can see the marker. Right now I use different symbol, and then line style is different. I just wanted to show you how you can create different symbols and line style width. Okay. How we can plot together, that means I showed you before. This is another example we have here. So we can add the data. Previously we named the data. We gave x equals or y equals the variable value, but we say that nope, we want to add them to here on the plot function, and then we want to plot the red color, and then the dot we want to add in our plot. Also, we just mentioned that what would be the x limit. So you can see after creating the graph, we adding the x-axis limit and y-axis limit. So it's just the red color dot we added. Here I change the markers size. So you can see that I added marker size function, and you can add the what should be the size of those markers. You can add that. You can also see that I added other parameters as well. So you can see within the x-axis and y-axis level, previously we just added the labels, the names, but then again we also added font size. That means what should be the size of those x-axis and y-axis labels. So we are controlling actually everything one by one. So we control the x-axis, the size, and then we added the x-axis, we added the width of the markers, and then width of the lines. You can also add more. You can see I added different line style. Everything else is almost similar. That means the width change. We did not mention the marker size. If you want, you can add that, just like I did before. And then if you want to avoid the line style, you can only add the marker, but we are not adding any line style. So you can see I kept it blank. So the marker color and then define parameters. Right now we are also controlling not just the marker size, we are also controlling the color of the marker. So this is another parameter we can add. So you can see I added the variables before, then I mentioned what should be the color of the markers, and then what should be the size, what should be the marker color as well. So let's see. So you can see that the in the marker we added different color, and then different symbol we have, and then size of the those points are different right now. So how we can add a title in a graph, and then how we can add a subtitle. So you can see that I added more examples here. You can see many more examples on this site, and then I added a simple example over here. You can see I created the variable first, and you can check what's the length of those variables. Then you can see I added similarly what we did before. I added the color and then symbol, line style, and everything else is similar. But over here I added a title. That means it will go on top of our graph, and then what's the size of those that title and where exactly you want it. On the y-axis, we are only mentioning in the y value what would be that, and let's check. Also underneath the title there should be a subtitle. Subtitle is says that sub, not sub, subtitle, and then you can add a subtitle, and then what's the font size, and then where exactly it will be. Also you can mention that what's the font size of x-axis and y-axis level. If I change the y-axis to, let's say, 1, you will see that it's going to overlap. Now you can see it's actually overlapping with my subtitle. And if I add let's say 1.5, and it will go way above my graph area. So that means you need to think about where you have your graph and then where you want to add them. So it depends on the size of your graph. Let's say the size of the graph, I would say this is 1. So this is 1, and then if I want to add another graph will be another size. So since we said 1.5, that means in terms of the graph area we have in y-axis level, that means this is 1, and then if I say 1.5, so it will add the halfway through, that means 1 is here and then 0.5 is here. If I say no, I would like to add a title where I would like to add it after let's say this is here is 1, here is another graph up to 2, that means it will add somewhere here the title. So you can see where it's adding, that means it's added just double the area. Okay, so I found that this is the best if we add 1.06, and then also you can think about where you want to add that the subtitle. Let's say we added it 1.5 and then 1.2 or 3. Okay, so you can see they are pretty close, and if you want to add some space, let's say 1.09, you can see that means it's going to be on 0.09, and then the title is in 1.5. Okay, let's go back to the previous one. That was the best, 0.93. Okay, so it's based on the graph area we have. Now the subplot. So in subplots, it's a little bit complicated. Not complicated, but you have to think about how you are plotting them. So let's say we have 4 by 1. That means 4 rows and then 1 column. That means we have 4 graphs. And every time you have to say which one is active. So that means, let's say I have graph number 1. So let's say I added 2 graphs. In those 2 graphs, when I'm adding the graph number 1, then I have to say this is 1. When I'm adding graph number 2, I have to say graph number 2. That means this is 2. So you have to make sure that which graph you are adding. Let's show you in an example. So over here we have a multiple graphs we are going to create, and we are also going to save it as a permanent file, as a PNG file. You can see where you kept this workbook, this notebook, it will save your file, save your permanent file over there. So you can see that we are creating 2 by 2. That means we are creating 4 graphs. Let's create them first, and it will be easier for me to demonstrate. So what here we are creating 4 graphs. In that 4 graphs, I created the data first, so you can use different data. I just use the same data. Just it's easier to explain. So you can see that we are creating 2 rows, 2 columns. That means you can see I divided the area into 2 rows, 2 columns so that we can have 4 graphs. If we only want top area, let's say we want 2 graphs only side by side, then we have to say 1 row, 2 columns. If we want to create top and bottom, then we have to say 1 column, 2 rows. So that's how it works. So at first we are going to work on the first graph. The first graph is this one. So that's why we have to say which one is active. So let's say we am working on at first the first graph, this top graph, and then we say that plot x by y, and then this is the top graph because 2 by 2 graph, but then this is the first one we are working on, and we added red color. Second one is the is in the second position. So you can see I added yellow graph. So that means this is 1, this is 2, this is 3, this is 4. And then I mentioned which graph I am right now on. So you can see I added 3, I added 4. After adding all of them, I adjusted a little bit. It's a good practice to have a tight layout. It's not absolutely necessary, but I found it's useful so that we have everything lined up. And then I also added the adjusted the top area so that we can have some space. We can add a title over there. So you can see I added a title. Added the title on top, and then I saved it as a permanent graph. So that's the function. Savefig is the function for saving the graph, and what's the resolution you want. I just added 300 dpi, as a resolution. In this activity, I ask you to create a similar graph, but increase the limit to 6. That means you can see it's limited to 4. The x-axis for all graphs should be increased to 6, and the y-axis limit should be increased to 10, so that we have more space. And then save the graph as activity3.png. Similar idea. Here is a little bit complicated in terms of how we are adding the data set. The graph is not complicated, but the data set. I hope you remember how we added the list comprehension a few weeks ago. If you forgot that, let me remind you. So we added in the list comprehension, when we create some data, then we add the function first, what we want to add, what we want to see as an output. Then what's in that output, we have the constant. You can see x is the constant. In that constant, where it's coming from, it's coming from p. That means each of those values in x is coming from the variable p, and then we created the variable first. So that's why it's complicated, but it's easy to add. So you can see that I am going to plot them. But before I define the variable and using the list comprehension, I say that plot them the 2x1 graph. That means first one is the first graph I mentioned here, 2 rows, 1 column. So in 2 rows, that means top bottom, we are going to add 2 graphs. Right now I'm going to work on the first graph, and then I plotted them, and I mentioned what should be the symbol and what should be the color. Same thing I did, similar idea I did for the last graph. So since we have 2 graphs, I mentioned this is the second graph I'm going to add in my top bottom graph, and I just added 1 data set in this graph. So you can see I added 2 lines in one graph, the top graph, and the bottom graph I just added 1 line. Four figures, 2x2. So you can see that there should be 4 subplot function because we are creating 4 graphs. And then I added the data set, I added the symbols, and I mentioned that what should be the limits for each of those graphs. So you can see I added same graph, but you can change the variable value if you want in each of them, and then plot them. Now I'm going to set the axis limits. We are defining them, and then we are going to say what should be the x and y axis limits. So later on you will see that I am going to add those. Previously we added together, now we can separate them. And we can also add a legend in our graph area, but we have to identify where we can add them. So you can see that the location of those legends where we want to add them, if you say best, where it will go, it will try to find some space where it can add them. Upper right, upper left, upper lower left. So based on where you want to add that, there is a code. So I gave you a picture where I showed them. So you can see that plot legend, we didn't say where to add them. This is just the default. It where it found a spot, it added the legend. Now I say that no, that means in the legend function, I mentioned the area log9. What is log9? The log9 is the upper center. That means upper center area. We added them, but make sure you are not overlapping any points. If you are overlapping, maybe add some space and then add your legend. If we say 4, it will be bottom right corner. You can see the lower right corner, and the other one is in the middle of our bottom area. Okay. So I added 2 data sets, and then I mentioned the parameters. Then I added the limits. So you can see right now I added the limits separately. and then I say that add a default legend. I didn't say what is it, where to add, and what to add. It just added when it found a space. Now I say that nope, I want to add a legend in this graph. So you can see we have few graphs we want to add. So you can see in one graph we added three types of data sets, and then we did 3 different points, and it found a spot here. It added the legend over here. But if you want to add in another area, so the lower right corner, because I saw that there are some space, as I said, you can also make a space wherever you want to add, then you can add that. And if you want to save your graph as a PDF, previously we saved as a PNG, now I'm going to add as a PDF. You can also save that. Let's say Control Enter, and then you can go back to your where you have this notebook. So you can see I created my figure 2. That's the graph we saved as a PDF. Okay, on the same folder where we have this notebook. If you want to add, let's say, an extra element that's not coming from your data, so you found some, let's say, some outliers, or you found some points or lines where you want to address in your paper, or maybe you want to show to the audience, then you can say that where you want to show. Sometimes we add extra text, and then we add an arrow so that we can show. So you can see that we can add text using the text function, and then you can say exactly where the coordinates is, x and y axis values are, and then exactly where you want to add. Or let's say you want to add the arrow and the text together, then you have to say annotate the text and the arrow points. Maybe it will be easier for you if I explain it in a graph. So you can see I added better text. That means where you want to, what you want to say, where you want to add, and then what's the coordinate for your arrow. So let's show you in here. Over here, I added 2 variables in x-axis and y-axis. We have 3 information, DBH and height, and then we added the parameters. After that, we said what are the limits of my x-axis and y-axis. Then I defined the size of those x level and y-axis level, the labels I added. Then I mentioned that add a text. Text is outlier, add a text, and then size of the outlier is 25. That means you have to, if you don't add the font size, it will add the default. Color is red, and exactly where you want to add that. So I said that in x-axis it should start from 1, and then y-axis it should start from 42. So that means I spotted an area, and then I said that this is the outlier value. You can see that the values we have in the data, this value is totally different than other values. So I wanted to point out here. That's why I said this is the outlier. So you have to identify where you want to add a text. Then I added in another text, and I would like to point an area or maybe a value, and then I added an arrow as well. This is a little bit tricky how you want to add that. So you can see that at 2.15 and 20, that means you can see 2.15 is somewhere here and 20 is here. That means this is where I would like to point the arrow. So you have to mention where, and then it will add an arrow starting here. But where is the end point? The end point, that means where the arrow will start, it will start related to this text. where is that text. So if you move the text, it will also move the start point of this arrow. And you can see that I said for the text, the expected growth, where it should be. So I say that it should be on x value 2.6, y value 15. If I change it to, instead of 15, let's say I change it to 10, then you will see that. So you can see I added it to 10. That means 2.6 is the x-axis value, but y-axis value is 10. So that means the arrow also started from there. So this is how we can move the text and the arrow. And then you have to make sure what you want to show. If you want to show the other points, then you can also, you need to mention where is that going to show. Okay. In this activity, I ask you to create the same, take the same code for the graph, but instead of showing the this point, I would like to show you this point. That means you have to move your arrow to show the third value and then add the text. Similar idea, but you have to play with how you can point the other point. So you can see that I gave you, but I like you to move around. And then take a look. Maybe it might be difficult. If it is difficult, then just fix one point and then move around the text and the starting value. Okay. And then I gave you a little bit more, so you can see the similar idea. What we worked on the multiple plots. So I created multiple plots and then different legends I added within each plot, but you can see I did not do well while I was adding this tick. That means x-axis tick, and then y-axis tick is fine. So that means we need to reduce the size of this limit. So I would like you to work on this so that you can manage to show all the x-axis limits. Right now it's not a good graph. If you want to know more, you can go to these links. You can see there are many types of graphs you can create in Matplotlib. Those are wonderful graphs. I hope you enjoyed working on Matplotlib. That's it for today. Thank you.